Now we are recording. You see the little pause button down there? To focus on graphing. Yay! Thank you. I appreciate the enthusiasm. So I guess, let's see what you remember. First of all, what in the world is a quadratic? Oh, my goodness. A number that's cubed? That was wrong on both accounts. Quad does mean 4, but in the case of a quadratic, it doesn't.
Oh, it's the square.
It's a formula. It does have a formula.
For the area, the graphing, shape.
Graphing of what?
The shape, right? The line thing.
What kind of line things? Oh! Parabola! Yes, if I had a piece of candy, I'd throw it to you. When I graph a quadratic, I get what we call a parabola. In its equation form, it looks like this, right? A, B, and C are coefficients. What's a coefficient? A number in front of a variable. Very good, right? So A, B, and C can be replaced with numbers, but to be a quadratic, the key here is this x squared part. Right? Y'all remember that a little bit? The x squared. And the 2, that exponent of 2, has to be the only exponent in there on x, okay? It can't have an x to the third. That would be a whole different kind. But for a quadratic, just x to the second. Yes? Say yes, because that's right. Okay. Yeah. So examples of quadratics might look like that is a quadratic. The biggest exponent on x is 2. I have the coefficients there. I don't have to have every single one of those terms. Those pieces are called terms. If I go too fast or you don't remember any of this, tell me, because a lot of this is kind of, what do you mean? Yes, it doesn't matter. It doesn't have to be any particular. Yeah, they can be any signs. Maybe this is negative x squared plus 7. That's still a quadratic, even though that x term is missing. It's actually not missing, it's a 0, which 0 has a very real function within our things here. Not to go too far too fast. Okay, can you identify a quadratic first of all? Everybody okay? All right. Now, you said it was a parabola, and you're absolutely right. What is a parabola? It is one of those things. So y'all have done this. It could be this, or it could be this. Okay, so it can go either way. And so it looks like this, or like this. It's a terrible rendition. But we're gonna camp out here for just a second and talk about a parabola and some of the special features that it has before we actually get into the graph. Ready? Am I going too fast? Ray always says I go fast, so tell me to slow down. Slow down, Ricky Bobby. All right. Slow down, okay. Tell me when you're ready. If you want to. You write down whatever helps you remember what you need to remember. Okay. Y'all are so cute, all y'all's little fancy notes, writing with all your highlighters and pens and whatnot. Okay. Meanwhile, I'm over with my pencil, just chicken scratching away. All right, let's look at a parabola. We'll open him up first. A happy parabola. You can. We'll get to some graph paper after a while. Right now, I'm just going to talk about some key features of the parabola. I would, so you can label some things. A big one. Tell me what you noticed. Tell me some things that. Okay, 2 arrows. So it goes in the same direction forever. They never intersect, right? And in fact, it's kind of hard to tell from mine, but they're kind of always working their way out, right? Okay, tell me what else you noticed. The minimum. Good job. Do you know that's amazing? All right. So a minimum. What's another word for the minimum on a parabola?
Axis. No.
Okay, it goes through an axis.
It's smaller. Axle. No, it doesn't have a Z in it.
A what?
No, it's one of those vertex.
Vertex! Yes, that's the vertex. Good job. It's the vertex. We got. It's the vertex. The vertex is where the minimum happens. It's the very lowest point on the parabola. Or if my parabola was, golly, I can't draw them upside down today. Get with it. Get with it. If it's this way, it's of course a maximum, but it's still the vertex, right? The vertex is very special for a lot of reasons. One, it's obviously that maximum or minimum point. The other thing that happens at the vertex, if you look at this graph, right, I'm going down. We read a graph the same way we read a book, which is left to right. So as I move left to right, I'm going down. Do you agree? So I say that I'm decreasing. This is the point when I stop decreasing, and what happens? I start increasing. So I change the way I'm moving. For that reason, sometimes this is called a change of direction point. Vertex is what you need to be most familiar with, vertex. We will.
Vertex means change of direction?
Yes, that means it's changing direction. That's exactly right. All right, now, Sawyer, you were fixing to say something else that happens through that vertex. And you actually said the first word of it, and then Max kind of piggybacked and stole it and said axle instead. But you said something before that. What was it? You remember? Axis. Axis. And I said it goes through it, right? If you were to draw a line straight through that vertex, they're the same on both sides. Give me a geometric term for that. Symmetrical. This straight through, we call it the axis of symmetry. It goes straight vertically through the vertex. Okay. Now, if I want to name that line, how do you give the equation of a vertical line? Yes, you're exactly right. Good job. X equals whatever this vertex was, right? So if this vertex, let's say this vertex was, I don't know, A, B, that's a point, right? A, B, then this would be X equals A that runs through it. So X equals is a vertical line, Y equals is a horizontal. Okay. So we've got these parabolas. They start out either increasing or decreasing. They change direction at the vertex. I've got an axis of symmetry that goes through the vertex. What else do I need to tell you about? Yes. So if you have this is the line x equals 2. If I came here, though, this is the line y equals 1. Horizontal lines are y equals, vertical or x equals. I always remember it because an x looks like an arrow pointing up and down. I don't know. Ooh, this graph. This is my least favorite way to graph a standard form. So I'm like, but we must do it. Y'all done with that? Can I move on? Before we actually graph, the equation itself can tell us a lot about the graph. Specifically, the coefficients that are in this equation. Okay, are y'all remembering this from Algebra 1? A little bit? Okay. First thing we look at, let's see. Well, why don't y'all tell me? Do you remember anything that this graph? Oh, no, not a thing.
I remember.
Okay. Do you remember anything you can determine from the equation about the graph? No. Okay. Okay, then I'll say. All right, first thing I want you to look at is that number on the very end. That number on the very end is special because what it does is it tells you your y-intercept. Oh, spell it right, Stacy. Intercept. What is a y-intercept?
Crosses the y-axis.
Where it crosses the y-axis. And if you think about this from back whenever you did intercepts in Algebra 1, the y-intercept is every time x equals 0, right? So if I put a 0 in for both of these x's, well, those terms just go away, and it just leaves me with this number off on the end. So that's going to give me my y-intercept. That's going to be very handy for you. Now, the other thing this tells you, this A right here in front tells you a lot of information. If A is greater than 0, so what am I talking about? Starts with a P. Positive. Positive A's. Every positive A. If A is positive, my parabola is going to open up. It's going to be happy. He's a happy parabola. If A is negative, what do you think happens? It opens down. It's a sad parabola. Okay, so first thing is the sign. The sign tells me up or down. The other thing that that A tells me is if I'm going to be really skinny or if it's going to be wide. Okay, and this is the kind of confusing part, so I have to be careful. I'm going to look only at, what do those symbols mean? Absolute value. So I'm only looking at the positive value of A because positive and negative tells me about which way it's opening. So now I'm talking about the size of A. So as the absolute value of A gets bigger, the graph gets skinnier. Because it's going to be the opposite of whatever you think it would do, right? So if I have a huge number out front, let's say 100 in front, what if it was y equals 100x squared? It's going to be a really teeny tiny skinny graph. Like the parabola is going to be like squeezed in as opposed to like this. No, I'm really sorry if you are. Are y'all hot? No. How about you burn up?
I mean, we have Edwards. What's going on with your hair? He got you there.
Okay.
See what's going on with his eyebrow. Yeah.
Something like Miss Arganduzo with her little fan up there.
She always has that thing.
Woo!
Always.
All right. As the absolute value of A gets smaller, now I want you to think about this for just a minute. If I'm talking about absolute value, so I'm not worried about negatives, and I'm getting smaller, what am I talking about? But what is the value looking like? It is positive, but how do you get smaller but not going into negatives? So I'm looking at what? Fractions and decimals, right? I'm looking at really, really small numbers, but not negative. So I'm fractions less than 1. Because what happens when A is 1, that's kind of my average parabola. So as A gets smaller, the graph gets wider. Let me give you a couple examples and see if you. By the way, if I said, whatever, if I said this, you know what that means? It's the same as y. Well, this means f of x. That just means it's a function. Okay, and it's the same thing as saying y equals. So if you see that, those are interchangeable. This just means we read it as f of x. We'll spend some time talking about that soon, but I just wanted, sometimes I slip and put that, and I want to make sure you understood it's the same thing as y. Same thing. Tell me what you know about that graph without even graphing. What's one? One is the y-intercept. That's exactly right. It's crossing the y-axis at 1. What else do you know? It's getting skinny. How do you know it's getting skinny? Because it's bigger than 1, right? It's getting bigger. It's getting bigger. We look at it compared to 1, essentially, since 1 is the average. It also opens up. That's exactly right. See how we're using those coefficients there to tell us what the graph is doing? Is it coming back to you now? It's all coming back. You know, I really like to sing, but God did not bless me with a singing voice, so I'm sorry. But I just will bust out songs sometimes, and y'all just have to deal with it. Does he? We'll get along just fine. Maybe we'll do a duet.
Or probably not the singing.
Hey, we've done. I've starred in quite a few of them. I've had quite a few. We'll watch the videos.
Can we watch Katie, please?
We will. We will.
Because I do it better than her, so no, we just don't.
Tell me what you know. Wider graph. It's a wider graph. That's right. It's getting wide.
Zero.
Oh, nice. I tried to trick you. Not the x-intercept, but the
Y-intercept.
y-intercept is 0. How do you know this? They want to know how you know. Not there. It's missing, right? And I can always throw a plus 0 on there and it keeps the same value. What else do you know? Wide and, that's okay, down. Wide and down. That's right. That's right. Negative is sad. It's very sad little parabola. Actually, very sad. Big parabola. Could be wide. Okay. I told you, squirrel. Squirrel. Let's just keep going. Y'all will get used to it eventually. One more. 5/2 x squared minus 12. Tell me what you know. I was trying to throw you off. It's skinnier, right? Because no, it's okay. That's why we're doing. Bigger than one. Right. So even though it's a fraction, it's a bigger than one fraction. So that's okay. Yes. Sometimes I had a student one time that said I could never write like a ransom letter because I write different all the time. Like, look at my 2s. They're different even in this problem. Like, he's like, Miss McGee, you'd never be identified because, anyway. Again, squirrel card. Okay, opens up. What else? Y-intercept. Y-intercept's what? Negative 12. So this time, what am I missing? The B in the middle, right? What value do you think B has?
Oh, it could be 1.
Could it though?
It's the X, right?
0. It's not there.
It's 0 because it's not there. And the reason it has to be 0 is because remember it adds there, so it's plus something X. The only thing I could add to keep the value the same would be a 0. Yeah. If you put a 1 there, then that would add a value in there. I'm glad I made something click for you today. I feel like I'm... All right, y'all ready? Nothing left but to graph it. I've shown you everything I possibly can about a parabola other than how to graph it. So are y'all ready? I think so. Actually, I could show you one more thing before we graph it. I think I'll show you how to find the vertex first, and then I'm going to actually do that. Remember how I told you that vertex is really important? I would say it's almost the most important, other than we'll get to the zeros pretty soon. But for right now, for our purposes, it's pretty much the most important. So you need to know how to find that. Okay? How do we find the vertex? I'm going to show you an algebraic way to find the vertex. So we've got this equation, ax squared plus bx plus c. Any of those are missing, zero what? Zero. Keep that in mind as we go, okay? A vertex has two parts. Do you agree with me? If I'm graphing, what are the two parts of it? An x and a y. I need two parts to make a point. I need an x and a y. We're going to find the x first, then work on the y. So to find the x, I'm going to give you a little formula, and you just have to commit this to memory, okay? You ready? Opposite b, not negative b, even though that's what I wrote, opposite b, okay? Because if I say negative b, you think it's always negative. Opposite b over 2a. It's a piece of it, but not the whole thing. Well, because what if it starts out negative? Then it becomes positive. So I always say opposite because I feel like it clears up a little bit of confusion. Yeah, you can do whatever helps you remember it. Okay, opposite b over 2a. Now this is giving me the x part of my vertex. And the x part of my vertex is really important because it's also my what? Somebody say it. The x part, change of direction, but the x part is also my what? Keep going. That is all the words I have written on my paper. Yes, it's the axis of symmetry. Thank you. This is going to be my axis of symmetry. So, yeah, there you go. A for axis.
Oh, wait, it was X for A? Yeah. X for axis.
X for axis. There you go. There you go. Whatever helps you remember it. Okay. Opposite b over 2a will give me the x part of my vertex, which is also my axis of symmetry. So 2 and 1. Look at there, it's a twofer. All right. Now, once you have an x value and you're talking about a graph, and we said it's got two parts, it's got an x and a y, how do I find that other part? How do I find the y? You look at the equation, you plug it in. You plug in x and find the y. This literally says y equals whatever. So what I'm going to do to find y is I'm going to plug in that equation. So I'm kind of giving you the steps, and then we're going to do an example, and then we're going to pull everything all together. I don't think we're getting through all three versions today. I think we're only doing standard form. There's 3 different ways to graph parabolas. Standard, intercept, vertex. I had all intentions. I've got everything run for 3 versions, but this is going to take a little longer than anticipated. Yeah. Yeah. Vertex. It's boring. It is, and it takes so long. And I think, too, because I give you all that background information to start with, too. I'm sorry. I'm trying to keep you entertained. All right. Let's do an example. Ready? Ooh. Whatever that is. 2x squared minus 4x. Find the vertex. Mark, set, go. Do what? Find the vertex. That's half of it. Keep going. Keep going. Yeah. Yes. That's exactly right. Yes, that's correct. So whatever it is, opposite sign. This one was easy. This one was easy.
This is easy.
Show me what you put. At least show me where you plugged them in, like here. They won't all be this easy. Only this is, yeah.
Are we supposed to solve the original
Oh, you have to plug it in.
Yeah, that's what you plug in to find the Y. Well, I just replaced every X with the X that I found to find the Y. Yeah.
So with this paper,
I'm gonna pretend like, hey, what is
All right, did everybody get one -1 for your vertex? Plug 1 back into that equation, that Y equals equation. So okay, now remember your order of operations. You have to square first.
so
And
this
then
is
multiply.
What I did the
Don't
vertex,
multiply then square.
I did the vertex and I got 4/4, which was 1. But I had to plug it back into the formula.
Yes,
and
to
then
find the
second
Y.
one- Okay.
I do remember this. Oh. So order of operations your order of operations are I have to square this, yes, so it's 1 squared, so then this is really 2 times 1, which is 2, right, and then you go left to right. All right, can everybody get that before we move on? All right, well then let's do one. Six problems. I tell you what though, it's 1:15. I'm gonna give you this homework sheet, and we're gonna do one of them together as an example, and then. But maybe you should do it on the back, so you have. Well, I'm gonna give you. I don't always do steps for you guys, but I There's not a lot you have to remember, but you have to remember. Yeah. What? I am. Done. It will. It will. Give it good. We'll just start with number 1, I guess. I'm gonna show you. All right. So this is the first one on the homework sheet that's coming around to you. Homework/classwork sheet that's coming around to you. Once you got it, if you want to go ahead and work ahead, you're more than welcome to. If you don't want to continue to watch me, that's fine too. So here's what we're going to do. I'm going to give you some steps in how the easiest way to tackle this in graphing, and we'll graph it together. It'll take me a little while to get through the one example it's coming around to you. It won't take you that long to graph every single one. Remember, I'm explaining steps as I go. Everybody always says it took. I'll put her down. Okay. Mr. Denzel, right next door to
this hallway, second door on the right.
All right. Step 1. Find and plot. Before we do this, tell me what you know just looking. Just looking, not doing any type of work. It's happy. So, and what? Standard width. That's right. Standard width. What else do you know? Y-intercept is -3. Right off the bat. If you got money in your pocket and you don't owe anybody money, aren't you happy? A positive potato.
Yeah, Coach King has a positive potato.
Lord, huh? Okay. Okay, let's do it together. I'm gonna do it with you. Find and plot the vertex. Step 1. You can find the vertex. We just did that, right? Opposite B. So 2 over 2A. Plug it back in to find the Y. Tell me if I make a mistake. Oh.
So it's just 2 or 0? Oh, okay.
What? Where are you getting 0?
I thought,
Plug it in.
oh, because it's an X. Okay.
1 minus 2 minus 3 is -4. So tell me what the point is. What's the vertex? 1, -4. Everybody okay? Find and plot. I found I didn't plot. I'm assuming everyone in here, please, sweet baby Jesus, can plot a point. Is that a yes or a no? All right. Now, here's the part where students kind of start getting confused because you can go in different routes here. I need to find one other point. I'm actually going to stay on this find and plot the vertex. I'm going to put / axis of symmetry because it may help you to kind of dot in that axis of symmetry. So you kind of dash it. All right. I need another point to plot. Okay. What is the most logical point to plot here? The y-intercept. If you can, use it. Why not? I call this an easy point, okay? And I do that because if you can use y-intercept, use it. Use y-intercept. Do it. What kind of situation would you be in where you couldn't use the y-intercept? Well, or yeah, like it's too big or too small. What other kind of situation could you absolutely not use it? What happens if the vertex sits on the y-axis? Right? Then I'd need another point. So how might you find another point? Well, all you have to do is pick an x that's close to your vertex and plug it in the same way you did with your vertex, right? So it might be that you have to go through finding a point that way. So like maybe I couldn't use the y-intercept, and maybe I said, okay, well, 3 looks easy to me. I'm going to plug in 3 for x and find the y that goes with it. Does that make sense to everybody? Yeah, I will. Okay, for this one, I'm going to go ahead and use the y-intercept so I can get through this example so everybody that kind of understands can get to work on their stuff, and I won't bog them down. So we said that this was -3. 1, 2, 3. Now, the last step is my very favorite step. Because what did you tell me in the very beginning? It's symmetrical. All I'm going to do is take that point, reflect it over the axis of symmetry. Do y'all remember how to reflect? Just like a mirror, just boop, flip it over. Reflect and connect. It's a very catchy little step. Reflect and connect. So I count over 1 to this, and then I count over 1 more. So it'd be 2, -3. That's exactly right. Do not make it a point. It's not don't make it come to a point when you connect it. It's not an absolute value graph. It's nice and curved there. And so then we can just connect, and I have my nice little parabola. Vertex, easy point, reflect, and connect always. That's all I'm going to make you. Because we're going to focus a lot on calculator for a lot of these, but you do have to be able to do some of it by hand. So this is the by hand part. I only make you find 3 points. Yes, I will. Yeah.
How big does the parabola? Like that too small.
Oh, that's good. That's good. Make sure you put the arrows on the end. Some people will stop, but yeah.
I feel like mine
Does it
kind of looks
matter how?
It will just kind of smooth it out here around
doesn't
there.
matter where the arrows they might not hit the right place.
That's okay. It'll catch enough of them here. Well, yeah. What was your question?
Oh,
All right. So several of you said, what happens if I can't use my y-intercept as my easy point? You're going to see that happen in number 4. What's your vertex in number 4? Find it real quick. It does, so that means it's down and skinny. That's exactly right. Y'all are exactly right. X is 0. So y is 8. So that tells me that my vertex is here. But it is going, how do you know it's going down? Because it's negative. That's exactly right. It's going to be skinny or wide. Skinny because of the 4. Right. So my axis of symmetry is also running right on that axis. So I can't use the y-intercept as my easy point because the vertex is my y-intercept. So I need to pick one, and I'll tell you, the further away you get from the vertex, the more it just gets really, really big or really, really small. So the closer you can stay to the vertex, the better off you're going to be. So what do you see that would be easy to plug in that's pretty close x-wise to the vertex? -1 or +1. Either one I'd go with. I'd probably choose +1. So we're looking at x's, right? If this is 0, then close to it would be 1. So for my easy point, I'll say let x be 1. Well, if x is 1, what's the y that goes with it? Let's see. Plugging it in, it is. It's is it +8? Oh, I was gonna say, golly, it should have given you, yeah, it's 4. 1, 4. Is that what everybody got? 1, 4. Okay, where are you confused?
I got 0 next.
Okay.
Let me plot that.
Okay, plot that.
all right. Hey.
So because I started at 0, what I usually do is look at the vertex where I started, and I just go, okay, what happens if I add 1 to that? That's how I got x1. I stay really close to where I started, and then you just plug in.
And then for
Yeah.
you got 0, you get 0 divided by those numbers will be 2.
It doesn't matter what those numbers are because it's 0 on top, right?
Okay. So we put out 1.
Yes. So now 1. Thank you, whoever did that. 1, 4. It is upside down, but shouldn't it be upside down? Should it? I don't know who said that. Did you say that? Yes, because of the negative in front. So yes, it should be upside down. Right. No, what do you mean you already figured them out? Okay, why did you plot it one? No, don't plot it 1 and 1. That's just the X part that I picked, to plug in. Like, if X is 1, what Y goes with that? And so I plugged it back in this equation to find out what goes with it. Right, right. So it's 1, 4, and then I just reflect and connect. Reflect and connect. See how it's skinny? And it's down, as it should be. The y-intercept is 8, as it should be.
Really big number.
Which one? Shut up. Opposite B over 2A